Hello everyone, I am Lianavil F Estares from BEED 2A, and we will discuss about the changes that material undergo. So let's start. As we can still remember, matter is anything that makes up an object, occupies space, has mass, and is composed of atoms. Matter can change in a variety of ways. Some changes alter the appearance of matter, while others create new and different matter. Matter can undergo physical or chemical change. In general, many physical changes can be reversed. Matter undergoes two types of changes. The states of matter, solid, liquid, gas, are sometimes referred to as phases of matter. Matter can change phases and not change composition. This is known as a physical change. The key word is physical because things only move from one phase to another by physical means. If energy is added, like increasing the temperature or increasing pressure, or if energy is taken away, like decreasing the temperature or decreasing pressure, substances can be made to physically change into the different phases of matter. The easiest way to do this is to heat or cool a substance. This allows heat to flow into or out of a substance. A physical change in which only the shape of the matter changes, or there is only a change in the physical appearance of matter. There would be no new substance created. Although the matter may take on different form, to put it in another way, physical changes only affect the appearance of matter, not what it is made of. Physical changes are limited to changes that result in a difference in display without changing the composition. Some common changes, but not limited to, are texture, color, temperature, shape, change of state, the boiling point, and melting point are significant factors in determining this change.
One of the examples of physical change is cutting foods, because only physical property of food is changed and no new substance is formed. The properties of wood remains the same.
Changes may be reversible, especially phase change. Physical phase change in which matter changes to a different form.
Melting ice is an example of physical phase change, since it simply involves a change in the physical state of water from ice to water in the liquid state. Furthermore, no new chemical substances are created throughout the process, and the transformation is reversible. Freezing the water will turn it back into ice. That is why it is a physical phase change.
Most of the things that we observe around us generally exist in three primary forms of phases. First is solid, second is liquid, and lastly, gas. The phase of the matter is temperature dependent. With the change in temperature, every material changes its phase from one state to another. But have you wondered of how does the heat affect materials, or where does this water go? So in this lesson, we will be focusing on the three states of matter, which are solid, liquid, and gas. Of how does heat affect some materials and where did water go? But first, let us define the word heat. Heat. It is the transfer of energy from a higher temperature object to a lower temperature object. When materials or objects are heated, they change their size, space, and texture. And when heated, some solid materials are changed to liquids. What do we call it? That is the process of melting. Melting is the process of liquefying due to heat. When materials undergo melting, it turns from solid into liquid. The changes of the state of matter of one object is because of the high temperature that had been caused by the heat or increase in temperature. But there are solids that even if not heated can melt, just like ice. And there are solids that need the heat of fire to melt, like crayons and glue sticks. And the heat causes the other solids to melt. The range of temperatures at which a solid becomes a liquid is called the melting point. When heat is applied to a solid, the molecules inside the solid begin to flow past each other, turning the solid into a liquid. So, let us now observe the candle when it is exposed to heat. As we can see, the candle melts due to heat or high temperature, and it changes from solid to liquid. Some examples of melting are cheese, crayons, and ice. The next is vaporization. The paste change from liquid to gas. Vaporization and evaporation generally refer to the change of liquid into a gas. The range of temperatures at which a substance changes from a liquid to a gas is the boiling point. Vaporization and evaporation are the same change of state. The difference between them is where paste change takes place in the liquid and how fast for this change occurs. When water is heated, it evaporates. The molecules move and vibrate so quickly that they escape into the atmosphere as molecules of water vapor. The heat causes the temperature of the water to increase, causing it to convert into gas or vapor. The liquid molecules are also separated. Heat causes the molecules in the liquid to move away as the temperature rises. As a result, the liquid turns into gas. The rate of evaporation is dependent on the temperature. As the temperature increases, the evaporation rate increases. Another illustration of evaporation may be found in a simple glass of water. We will put some water in a glass and set it close to a sunny window. We will see that the water in the glass begins to evaporate over time. So evaporation is at play. Hand sanitizing is another example. When we apply hand sanitizer, we may notice that our hands dry quickly. Why? Because alcohol has a lower evaporation point than water. So, it evaporates rather quickly from the heat of our body. Other examples that we can observe in our daily life is ironing clothes, kettle whistle, and drying of wet tables. Then, sublimation. The paste change from solid to gas. Some solids are able to go straight to the gas phase without becoming a liquid, caused by heat or increase in temperature. The heat causes other solids to disappear and become gases. Think of the smoke coming off dry ice.
Melting, evaporation, and sublimation are the effects of heat on some materials.
So now, we move on to the next type of changes, which is chemical change, in which matter is changed in a way that cannot be undone, like foods ripening or food cooking. It involves the production of a new substance. The product of chemical change cannot be brought back to its original state by ordinary means. The new substance formed is entirely different from the original substance. Just like, for example, the burning of wood, the digestion of foods, and rusting of nails. Matter is all around us, and these have three states of matter, like what I have mentioned earlier. And one of those is solid. Solid has definite shape and volume, as well as they have fixed shape and size that takes up space, and solids can also be held. Solid materials are the objects that undergo changes in their characteristics or properties. And what are those properties? Those are the size, shape, color, texture, and weight. Then what are the ways of changing solid materials in terms of those properties that I have mentioned? Solid materials can be changed through many ways. It could be by cutting, tearing, folding, twisting, hammering, coloring, stretching, melting, pressing, bending, and others. But let us focus on the bending, materials that can be bent, pressing, materials that can be pressed, hammering, materials that can be hammered, and cutting, materials that can be bent. And what are those materials? But let us define the word bend. Bend is to turn or force an object from a straight form or even to curve or angular one. So the solid materials that can be bent may change their size and shape, but there would be no new material formed because only the physical appearance of the materials is being changed. Let's say, for example, the metal spoon and the plastic spoon. Let us now observe and describe what happens to each material. If we bend the metal spoon, we can observe that there is a change in its physical appearance, but it doesn't break. It is because of the ability of ductility in which shapes can change without losing their strength or breaking, and no new materials have been formed. But if we bend the plastic spoon, there would be a change in its physical appearance, as well as in its shape and size. And those changes are what we call brittle, in which it can be easily cracked, snapped, or broken. Other examples are soft plastic ruler, because as we bend it, it only changes its form or its shape, size, and physical appearance, not its chemical composition. Then rubber slippers, belt, paper clip, and many more. Bending of solid materials can also be applied in situations like bending of steel bars or iron in industry, in constructing concrete houses or infrastructures, roads, and more. There are many metals that can be bent without breaking it, in which it can be formed into the desired shape by bending or molding. And some metals are soft and easily bent, such as aluminum and others. A metal that is easily bent is what we call malleable.
So now we move on to the solid materials that can be hammered that will be reported by Shamen E. Estropia.
The second sub-activities that solids can be changed is solids can be hammered. But first, what is hammering? It came from the word hammer, which is a hand tool usually consists of a solid head held on the end of a handle. It is used for beating or striking or pounding the materials or objects to change the shape of the material. So let's see what happens to the solids materials when it hammered. As we can see, an empty can and a hammer is used in this activity. So let's see what happened to the can when it hammered. As we can see, the shape of the can changed as its original shape. There are more solid materials that can be found in our house. A hollow blocks, a can, or any solid materials that can be hammered. Always remember that when solid materials are hammered, they may change their size and shape and even the texture. However, no new material is formed because only the physical appearance of the material is changed. Additionally, gold and silver metals are the most malleable metals that can be hammered and formed into shapes, which are made into jewelry. What element can be hammered or rolled into shapes? Aluminum can be hammered into different shapes or rolled into flat sheets. Thin aluminum foils are widely used for safe wrapping of medicines, chocolates, and food materials. This means that aluminum is malleable. Metals are elements that are characterized by being ductile, malleable, and lustrous. So let's move on to the third sub-activities, which is solid can be pressed. So first, let's define the word pressed. It is applying pressure to flatten and shape an object. So let's observe this video. In this activity, a disposable cup is used. When we apply pressing in this object, it changes its shape. A good example of pressing is when we're baking a bread. As you can observe, it applies pressing to the dough to desired shape to form the cookies or a bread. Next is a cotton. No changes on the physical appearance when it pressed, but only it changed its shape. Other than that example video, there are a lot of solid materials can be found in our home, like modeling clay, a dough, banana, sponge, cotton, and etc. So what changes when material is pressed? When solid materials are pressed, they undergo physical change. No new subject is formed but it changes its form, texture, size, or shape. Why do most solid materials change their shape when pressed? It is because solids behave as they do because of the way their particles are arranged. The particles of a solid are linked by strong forces which pull the particles tightly together. So, although the particles can vibrate, they cannot move about easily. This arrangement explains why solids usually keep their shape and feel firm. And the last sub-activities that solids can be changed is no other than solids can be cut. What do we mean by cutting? This activity is when dividing an object with the use of a sharp edge such as knife or pair of scissors. So take a look in this video.
For this activity, it uses a knife to cut a tomato. So let's see what happened. As you observe, the size of the tomato changed as its original circle shape. Next is using a pair of scissors and a paper. So let's see what happens. As you can observe, the shape of the paper changed.
There are many solid materials can be found in a house, like a paper plate, candy wrapper, plastic cover, a piece of cloth, or a piece of cardboard, and many materials that can be cut. Some solid materials can be cut. These materials may change their size and shape, but no new materials is formed. Hence, only the physical appearance of the solid materials can be cut. But not all solid materials can be cut using scissors or a knife. Some solid materials like iron, steel can be cut using sophisticated cutters like metal cutters or machine cutters. What changes took place when solid materials are bent, pressed, hammered, and cut? So let's all be reminded that when solid materials are bent, hammered, pressed, and cut, they may change their size and shape and even the texture. However, no new material is formed because only the physical appearance of that material is changed. So that's all for our topic, the materials undergo changes. Thank you for listening.
So now let us discuss the strategy that we can use in teaching the changes that materials undergo. So the strategy or approach that we can use in teaching the changes that materials undergo is 5 E's. First, engage.
Opening a lesson with an activity or question meant to engage students, snag their interest, and offer the opportunity for them to share what they already know on the subject. Here is an example of engage. Where students will write down on the manila paper some examples or solid materials that can be bent or hammered, pressed, cut, any of those. Then list down materials in 2 minutes. The group with the most number of correct answers will win the game.
Second, explore.
Through their experiments or other interactions with the material, they deepen their understanding of the content. The explore session promotes interest in and curiosity about the changes that material undergo, in which students carry out hands-on activities. And here is the example of explore.
Third, explain.
Once they've explored, students attempt to explain what they have learned and experienced with help from the teacher, who only then explains concepts or terms encountered during exploration. Then the teacher will discuss about the changes that materials undergo with the participation of its students. The fourth is elaborate. From there, students elaborate on their understanding, applying what they've learned to new situations to deepen their skills.
And lastly, evaluate.
This is the final phase. Students evaluate, reflecting on and providing evidence of their new understanding of the material, or this will review and assess the students' knowledge. The teacher will give an activity that will evaluate the learning of the students.
When choosing an instructional model, teachers seek strategies that help students gain a complete understanding of new concepts. They aim to engage students, motivate them to learn, and guide them towards skill development. One of the ways to do that is by incorporating inquiry-based approaches like 5E model, which is grounded in active learning. Teaching and learning progresses have the 5 phases: engage, explore, explain, elaborate, and evaluate. The phases of the primary connections 5E teaching and learning model are based on the 5E's instructional model. The 5E model allows educators to create a unique learning experience for students. Teachers who can incorporate instructional models like 5E model into their classrooms help students build a strong foundation of knowledge through active participations. Teachers use the 5E model of instruction to sequence lessons and activities which provide best first instruction for all students. Through this process, they emphasize opportunities to personalize learning. It is important to avoid front-loading and to instead allow students to develop an understanding through engagement and exploration. These experiences allow students to understand the concept, even define it before a term is presented. This gives the students the opportunity to discover the concepts on their own and something to connect the terms to. Students can then elaborate or apply the new concept to related phenomena for a deeper understanding. The 5E model is most effective when students are encountering new concepts for the very first time because there is opportunity for a complete learning cycle. According to co-creator Roger Beatty, the 5E model is best used in a unit of 2 to 3 weeks in which each phase is the basis for one or more distinct lessons. According to Beatty, using the 5Es model as the basis for a single lesson decreases the effectiveness of the individual phases due to shortening the time and opportunities for challenging and restructuring of concepts and abilities for learning. And if too much time is spent on each phase, the structure isn't effective and students may forget what they've learned.